Good afternoon, Doctor. I'm Jingze from Group 2. Today, I'll be presenting our video for Skill A Project 4. So, first of all, let me introduce our team, which consists of Xin Hui, Yu Ting, and me, Jingze, and also Elvis Chang. So, next will be the problem background of this project. As computing technology advances, selecting the most suitable computer processor or CPU becomes increasingly challenging. The wide variety of CPUs available in the market, coupled with complex factors that influence their performance, make it difficult to make informed decisions. To address this, CPU benchmarking has emerged as a valuable practice. By subjecting CPUs to standardized tests and measurements, benchmarking allows for objective performance evaluation and comparison. However, understanding CPU benchmarking requires knowledge of underlying architecture and performance metrics. These projects aim to provide hands-on experience with CPU benchmarking, enabling students to explore benchmarking tools and methodologies while developing skills to measure CPU time through assembly coding. So next will be the aim of this project. So by conducting this benchmarking test on our own laptop, which is Acer Swift 5 and Lenovo Legion 5, we have the opportunity to gain a deeper understanding of the hardware components and their associated performance metrics. This hands-on experience allows us to go beyond implication on the various hardware specifications. By analyzing the results, we can identify the limitation of our computer and able to understand more on it. Other than that, we will have a deeper understanding of the benchmark and how to analyze the result of the benchmark test. So next will be the objective of this project. So first of all, I think the objective is to explore CPU benchmarkings, which allow us students to familiarize with CPU benchmarking and its significance in evaluating CPU performance. Next, we would be hands-on experience with benchmarking tools. This project provides us students practical experience using benchmarking tools to run tests, analyze the results, and interpret the performance metrics. Third would be allow us to compare different systems. So in this case, it allows us to compare the performance of two different laptops using standardized tests and criteria. So four would be the measure CPU time with assembly coding. So this project enhances programming skills by writing assembly code to measure the CPU time in the part 2 of the project based on the given math equations.
My name is Lee Xing Hui. Now I will present part 1, which is benchmarking of CPU. We use two benchmarking tools, which is CPU-Z and SPECI. CPU-Z is a versatile utility software that provides detailed hardware information about a computer system, with a focus on the CPU. Its key features include displaying CPU details like name, architecture, core count, clock speeds, and cache size. It also provides information about the motherboard, memory, and graphics card. CPU-Z offers real-time monitoring of parameters like CPU utilization, temperatures, and voltage, and generates reports. It also includes validation and benchmarking features for system verification and performance assessment. CPU-Z is portable and can be run from a USB drive. Overall, it is a valuable tool for hardware analysis and optimization. For SPECI, SPECI is a versatile system information tool that provides detailed hardware information and system specifications. Its features include comprehensive system overviews, detailed hardware insights, temperature monitoring, disk health analysis, network information, customizable reports, and a user-friendly interface. With its ability to provide in-depth hardware information and real-time monitoring, SPECI empowers users to make informed decisions, troubleshoot issues, and optimize their computer system for optimal performance. This is the computer specifications for both laptops, which is Acer Swift 5 and Lenovo Legion 5. From hardware comparison of our two laptops, which are Acer Swift 5 and Lenovo Legion 5, we found that Acer Swift 5 has Intel Core i5 1135G7 and 2.4 GHz, while Lenovo Legion 5 has Intel Core i5 11400H and 2.7 GHz for CPU part. The i5-11400H has higher number of cores and threads, and also higher base clock speed compared to i5-1135G7. Hence, Lenovo Legion able to handle more simultaneous tasks and have better single-thread performance compared to Acer Swift 5. In the RAM part, Acer Swift 5 has single-channel 8GB memory, while Lenovo Legion 5 has dual-channel 16GB memory. This means that Lenovo Legion 5 has more memory compared to Acer Swift 5 because dual-channel memory increases memory bandwidth. Furthermore, Acer Swift 5 uses Intel Iris Xe graphics card, while Lenovo Legion 5 uses NVIDIA GeForce RTX 3050 graphics card. This shows that Lenovo Legion 5 is more powerful compared to Acer Swift 5 because RTX 3050 capable of running demanding games and applications more efficiently. For the motherboard and audio driver, both of the laptops are different. These aspects generally have minimal impact on overall performance. Hence, we believe that Legion Lenovo 5 should perform better than Acer Swift 5.
My name is Wang Yuting. So now I'll present the benchmark execution and results. So this is the result that we get from the CPU Z with no application running of the both laptops, which are Acer Swift 5 and Lenovo Legion 5. Okay, the comparison and discussion that we get is we can evaluate the CPU performance using CPU Z on the Lenovo Legion 5 and Acer Swift 5 laptops with no background application running. The results show that the Lenovo Legion 5 outperforms the Acer Swift 5, particularly in multi-threads performance, while both CPUs belongs to the 11th generation Intel i5 and has similar single-thread performance. The Lenovo Legion 5 has a higher number of cores and threads, allows for the better multitasking, and improve the performance in multi-thread workloads. In summary, the Lenovo Legion 5 performs better than the Acer Swift 5 in both single-core and multi-core scenarios when only CPU Z was running in the background. So the next one, we test for the 2 hours usage with working application and running. So the application that we run is the Google Chrome with 10 tabs running YouTube, video editing software, Microsoft Word, snipping tools, Discord, and Visual Studio Code. So this is the result that we get after 2 hours for Acer Swift 5 and the Lenovo Legion 5. Okay, so the comparison is under the same condition of running multiple applications, the Lenovo Legion 5 outperforms the Acer Swift 5 in multi-thread performance. This indicates the Legion 5 excels in tasks that can efficiently utilize multiple processor cores or threads, benefiting applications like video editing software and multi-tab browsing. Additionally, the Legion 5 has a higher RAM capacity and dual channel setup contribute to its superior multitasking capabilities. Overall, the benchmark results suggest that the Acer Swift 5 may have a slight advantage in single-thread tasks, while the Lenovo Legion 5 performs better in multi-thread scenarios and demanding workloads. So the next one is the 3 hours usage with application and game running. So the application that we run is same as the 2 hours usage, which are the Google Chrome, 10 tabs running YouTube, video editing software, Microsoft Word, snipping tools, Discord, and Visual Studio. And the game running that we have added is the Valorant. So this is the result that we get in the CPU set for the both laptop. Okay, so this is for the Acer Swift 5 and this is for the Lenovo Legion 5. So the comparison in these two laptops is the editing the game application Valorant to the benchmarking process revealed that the Lenovo Legion 5 outperforms the Acer Swift 5 in both single thread and multi-thread performance. The SSE5 experienced crash and higher surface temperatures during the benchmark, possibly due to its limited RAM capacity and lower numbers of cores and threads. In contrast, the Lenovo Legion 5 showcased better performance and stability, supported by its higher RAM capacity, superior CPU, and dedicated GPU RTX 3050 compared to the integrated Intel Iris Xe graphics in the SSE5. Consequently, the Lenovo Legion 5 is better suited for gaming and graphics-intensive tasks. The conclusion that we can make is benchmarking our computer is crucial for understanding their capabilities and limitations. It helps us make informed decisions based on specific needs. For instance, the Lenovo Legion 5 is better suited for gaming and content creation, while the SSE 5 offers productivity features with a touchable screen. Price is also a factor, with the Legion 5 being slightly more expensive. It's essential to consider our requirements and review benchmark results before select a lens for general usage.
Okay, so next we'll move on to part 2 of the project, which is the benchmarking of the CPU. But before moving on, I will show the execution of the coding in Visual Studio 2019.
Okay, so this would be the execution of the code for the part 2 of the project COA4. So first of all, we'll look at the instruction, which is to write an assembly language program to calculate the sum and the measured time taken to execute. In this case, I believe will be 1,000, 10,000 or 100,000 loops of the equations, which is the y equals to 3x squared plus 2x plus 1. So where x equals to our group number, the initial value equals to our group number. From the loop, we will loop from 2 to 1,002 or 10,002 or 100,002. Okay, so this is some of the instructions that we need to follow. So this is the code that we need to change it into assembly language and run it to get the CPU time. So this is the output required, which is the equation y, number of loop and value of sums, and the CPU elapsed time, and this is the example of the output. So we need to run on 2 different computers, but I will show it on my computers, and we need to compare the differences which is included in the report. Okay, so let's start. So as usual, we will declare the data, some of the variable, which is the msec1, which is to store the value of the CPU elapsed time before looping, and msec2 to store the CPU time after the loop, and x we declare it with 2 first because this is our group number, and y which is for the equations, and sum is to store the sum of all the y in each loop, and CPU time is to store the time for the CPU requires to run the loop or the whole program. So yeah, this is the loop. So loop number would be the number of loop we need to loop every time, which is 1,000, 10,000 and 100,000. So here are some of the output message, like the benchmark that need to be printed in the terminal for the output. So okay, so next we'll move on to the code. So we will start by recording the CPU time before looping. We will call this get m seconds function, which is get milliseconds, to record the CPU time in this moment, and it will store in the EAX. As you can see, it's stored in the EAX, and we'll move this value into the msec1, and after that we'll move the value of 0 into sum, and the value of loop number, which is 1,000 in this case, into ECX, and ECX is the looping. It's a flag that check the looping, and each time a loop is run, ECX will -1, and it will jump out of the loop after ECX equals to 0. Okay, so we will start the loop. So first of all, we will move the number of x, which is 2, into the looping, and we will multiply EX with EAX, because as you can see, the equation y is equals to this. Equation of y is equals to 3 to the 3 multiplied by x to the power of 2. So as you can see, EAX minus power of EAX multiplied EAX, it will equals to x to the power of 2. And next we will move 3 into EBX, and we will multiply EBX with EAX. So as you can see, 2 times 2 is 4 and 3 times 4 is 12. So you can see EAX has the value of 12, and next we will store the value of EAX into EBX first, and we will use it for later usage. So after that, we will move the x into the EAX. So for doing the second part of the equations, so we will move 2 into EDX, and we will multiply EDX with EAX. As you can see, just now the EAX is stored with the value of x, which is 2. So now 2 multiplied by 2, we will get 4 for EAX. So yeah, you can see 4 for the EAX, and we will store the value of EAX into EDX first. Then last, we will add up these two, which is add EDX into EBX, and we will increase the EBX by 1. As you can see, EBX now is 16, so we will increase it by 1, it will equals to 17. And next we will add the EBX into the sum, which is 17 into sum. You see now sum is 7, and we will update the value of x because we need to loop x from 2 to 1002. So yeah, this is one time of the loop. So we will start with another round of loop. So after the looping, we will call another get m seconds and to compare and store into msec2, and we will compare the CPU time after that. So I will add a breakpoint here to show the F5. But why we are using F5 instead of F10 here? Because it's impossible for us to F10 for the every loop, because we need to get the real time for the execution of the equations of the CPU. So when we F10, the time is not accurate. The time is equals to the time we press for every F10. So what we need to do is we need to run here all in one time first, and then we will F10 one by one after that to show everything. So I will F5 until here. As you can see, it's called the get m seconds already, and the msec1 is also stored already, and it finish the loop. So now we will get F10 one by one. So we will store the value of the get milliseconds for the time after the looping is done, and we'll store it into the msec2, and then we will move it to the EBX, and we will subtract EBX, which is the msec2 with msec1. So yeah, as you can see, the CPU time now is 0, and the value of EBX is 0, because the time taken to run 1000 loop is very small, and it is lower than 1 milliseconds. So the value of the CPU time elapsed is 0. So we'll move the EBX with 0 into the CPU time. Okay, so now we will call one by one to call the output of the string. So here. So as you can see, this string is printed in the terminal. So next we will offset the loop message. Okay, so number of looping is also printed, and we will move EAX loop number, which is 1000, into EAX, and it will write the description in the terminal, as you can see here. Okay, so we will write the next line, which is the sum message. As you can see, value of sum is here, and we will move the value of sum into EAX, and we will write it into the terminal. As you can see, the sum of the value is written into the terminal. And last but not least, we will write the CPU time taken in milliseconds, which is 0 here, right? So since I have shown step by step for the running of this program with 1000, so for 10,000 and 100,000, I will not run it one by one with F10. Instead of it, I will run it with F5, which show the output in the terminal after all. So first of all, we need to change the loop number from 1k to 10k, which add 10. So we'll look at the result of the terminal. So as you can see, the number of looping has also changes from 1000 to 10,000, and the value of sum has also changes, but the CPU time taken is still under 1 milliseconds. So now we will increase the number of looping to 100,000 to see if there are any changes. Alright, as you can see, the number of looping has also changes to 100,000, the value of sum has also changes, but still the CPU time taken is under 1 milliseconds. So I will increase the number of looping to see that whether my program has problems or really the CPU time taken for 1000, 10,000 and 100,000 is really 0. So I will add 0 and I will run it with F5. Okay, so as you can see, so for 1 million time of looping, finally the CPU time taken has passed 1 millisecond, which show 2 milliseconds. So it takes the CPU 2 milliseconds to run 1 billion time of looping of the equations and calculate the value of the sum. So we can conclude that for this laptop, 1000, 10,000 and 100,000 does not exclude 1 milliseconds. So we will need to use a larger number to show the differences between two laptops, and this will be included in our report. So that's all for the showcase of the execution of the code.
I'm Elvis, and I will continue with the results of the implementation and execution of the code and the result analysis. So we will start by looping the equation for 1,000 times. So in this case, the CPU time taken for both of the machines to loop the equation for 1,000 times is 0 in the console output, which means that both of the machines only needed less than a millisecond to loop the equation for 1,000 times. Next, we loop the equation for 10,000 times. So in this case, the CPU time taken for both machines also remains 0, which is less than a millisecond to complete the task. Next, we loop the equation for 100,000 times. So in this case, SR35 needed approximately 1 millisecond to loop the equation for 100,000 times, while Lenovo Legion 5 only needed less than a millisecond to complete the task. From the results just now, we can see that when we loop the equation for 1,000 and 10,000 times, the CPU time taken is the same for both machines, which is 0. So we can't really use the result to compare and tell the performance difference of both of the machines. However, when we execute the equation for 100,000 times, SR35 took a slightly longer time than Lenovo Legion 5. This suggests that Lenovo Legion 5 might have a slightly more powerful CPU that can help it to process the instructions more efficiently. But the difference in the CPU time for the both machine is relatively small, and we can't really use that as a reference to compare the machine's overall performance, as the small difference might be influenced by some factors such as background processors, system load, and software optimization. So to have a clearer image on the performance of both machines, we added an additional test extending the loop count to 10 million. So when we loop the equation for 10 million times, the SR35 machine needed approximately 36 milliseconds to complete the task, while Lenovo Legion 5 only needed approximately 15 milliseconds. So the significantly lower CPU time of 50 seconds by the Lenovo Legion 5 implies faster response and execution times, indicating a more responsive system capable of handling tasks efficiently. Additionally, it suggests that the Legion 5 CPU can handle a greater number of concurrent tasks, resulting in a smoother multitasking experience. Conversely, the higher CPU time of 36 milliseconds for the SR35 suggests a comparatively slower response and potential delays, particularly under heavy workloads or resource-intensive process. So based on these observations, we can say that the Lenovo Legion 5 CPU exhibits higher performance than that of the Asus V5. Throughout this project, I realized the importance of evaluating computer performance. By exploring CPU benchmarking, I could measure and compare how well different systems work. This helped me understand their capabilities and efficiency. The CPU plays a crucial role in the overall performance, so it was really interesting to see that how benchmarking can guide hardware choices.
In this project, I learned about standardization in CPU benchmarking, which ensures fair comparisons. By following consistent methods and conditions, I obtained readable results. This showed me the importance of using standardized practices for accurate performance evaluations. I also get to know the game sequence function in assembly language.
Okay, so next would be the reflection on me, Xingze. So throughout the project, implementing the iterative loop to calculate the given equation require careful consideration of assembly language instructions, because since in the instructions the code given was not in assembly language part of it, which is the for loop is given in C++ or JavaScript, so I need to Google a lot to do the loop in the assembly language. And other than that, I also get to know more about how different specifications will affect the benchmarking's result. And I also able to analyze the result of the benchmarkings, which will help me in more to understandings. We not only look at the hardware of the specifications of the laptop when we are buying it or choosing it, we also need to see certain benchmark results for a deeper understandings in the machines.
The reflection of me is trying out different CPU benchmarking tools was a hands-on experience that improved my understanding of hardware performance. I got to use freely available software and see how it provided valuable insight into CPU performance. This knowledge can help when deciding which hardware to choose.
In conclusion, these projects not only enhanced our understanding of assembly language programming, but also provided us with valuable insights into benchmarking and performance analysis. It highlighted the significance of accurate measuring CPU time and the impacts of hardware configurations on program execution. The experience gained will undoubtedly prove beneficial in future endeavors involving performance optimization, benchmarking, and making informed decisions regarding hardware choices for computational tasks. This project emphasized the importance of precise measurement and optimization of code execution to achieve efficient performance and informed decision making. So that's all for our presentation. Thank you.